Alright, so this is an introduction to Newton's first law. And Newton's first law is defined as this. Object at rest will stay at rest, and an object in motion will stay in motion with that same magnitude and direction. So what that means is that if I have a bottle and I set it on the table, or a ball or anything else, that object will stay at rest on that table doing exactly what it's doing forever, unless some other force acts on it. And likewise, if I have a ball and I throw it into the air, let's say at 5 kilometers an hour directly in the air, it will continue going in that direction, 5 kilometers an hour, that direction of magnitude, forever, right? And I know what you're thinking is, well, if you throw it into the air, it's going to come back down. It's not going to keep going forever. And that's true because a force acts on it. And in this case, that force would be gravity. But if we were to go to space, and I was to throw a ball or a bottle or whatever at 5 kilometers an hour in a direction, it would keep going forever. Assuming there was nothing around it to mess with it, whether it's gravity or bump into it, it would just keep going forever. The same speed, the same velocity, on and on, right? And that principle is called inertia. So let's look at our vocabulary for this one. Force, inertia, mass, and weight. So force is defined as something that causes a change in motion in something. All right. Inertia is what we just talked about. It's Newton's first law. An object at rest will stay at rest. An object in motion will stay at motion. Right. And mass means like the quantity of essentially like elements or molecules in your body combined. So mass doesn't change. So if I have 100 molecules in my body on Earth, I'm going to have 100 molecules in my body on the moon or anywhere else, right? Now, weight is something that fluctuates. Weight changes. So weight is a product of your mass and the gravity of the body that you're on, so the Earth. So if I weigh 100 pounds on the Earth, because my weight is a product of the gravity of the Earth, which is 9.8 meters per second, times my mass, then that's why my weight will change. Because if I go to the moon, for instance, where the gravity is less, my mass is going to stay the same, but because that gravity is less, now it's, say, my mass is 100, and on Earth it'd be 100 times 9.8, whereas on the moon it might be 100 times, let's say the moon's gravity is, 4. So I'd weigh much less on the moon than I do on the Earth, which is why your weight will change depending on where you go, whereas your mass will always be the same. Okay? So that's a lot of what we're going to talk about. The first part of this unit will go over inertia, and the second part we will go over how to calculate your weight. All right.